Okay, the lab that we're dealing with today involves carrying out 24 double replacement reactions. Now, we're going to learn about double replacement reactions next chapter, but basically what a double replacement reaction is we combine two aqueous or solutions, water solutions, that contain dissolved ionic compounds, and we get either a solid, a liquid, or a gas. Now, the solid is called a precipitate. You caught me doing this during passing time, so we heard the bell. So it's called a solid that's formed is called a precipitate. Now be careful, when I have students define precipitate, they go to Google and they take the first hit, and that they tend to define it as rain, snow, sleet, or hail. That's precipitation, okay? A precipitate is a solid that is formed by mixing two aqueous solutions, okay? Now, what we've done is, normally this would be carried out in a well plate if you were doing this in class. Now, a well plate looks like this. It's kind of hard to see. Let me get a solid background. So it looks kind of like this, where we have all these little wells that we can carry out a very small scale reaction. I'm doing it on a bigger scale just so you can see it. But basically the idea is we're going to carry out a grid. So I have 24 beakers set up. This row I have put sodium carbonate in. This row I have put sodium phosphate in. And this row I have put sodium hydroxide in, just a very little bit. Now in your up and down columns, I'm going to put other substances that we're going to mix with it, and we're going to look and we're going to see what happens. And so what you're going to do is you're going to watch, I'm going to mix them together, I'm going to add them, then I will hold up kind of each individual beaker. You're going to need to write your observations down, and then you're also going to need to name the substance that's formed and write the formula for the substance that's formed. Okay, so this first column here is going to be silver nitrate. Okay, so I'm going to add a little bit in here, and you should see immediately what happens. And I will hold these up so you can see, so you can make an observation. So there's one. There's two. And there is the third one. Okay. All right, the next one is calcium chloride. Now, each of these precipitates can be kind of clumpy, can be kind of gel-like. I don't know if you can see this one, but it's a little goopier. It's thicker than the other one. They can be powdery. Okay, this one you can see it's a little bit forming, and this one's a little goopier as well. And this is one that would be powdery. See, it's still sort of liquidy. And if we let it sit, you're going to see the powder sink to the bottom. All right, this next one is aluminum nitrate that we're adding. Okay, so here is aluminum nitrate and sodium carbonate, and then you can hear there's little bubbles going off as well, which means a gas is being given off in addition to a solid. This one, see how it kind of just immediately gelled up and got goopy? And here's another one that's just kind of goopy. That's the scientific word, goopy. Okay. All right, next group is barium chloride. All right. There's a lot of similarities. This one is much more watery. It's not as gel-like. This one's a little thicker, a little more gel-like. And this one's very watery, very fine powder. Okay, cobalt chloride. We're getting some colors other than white now, which is kind of nice. Okay, so here we go. Now when we get to elements that are in the transition, Look at that one. Nice pretty color, purple. And it is kind of, it's a little goopy. It's a little gel-like. You get pretty colors when you deal with elements that are in the transition. Though barium, oh, this is cobalt. I was thinking barium. So here's another one. And this one is not really that goopy. You notice I shook it. Okay, and there actually was, I thought I heard a little bit of bubbling going on as well. Okay. All right, here's the lead. All right, that's kind of powdery. That one's powdery as well. Very fine. That one as well. That one's a little more gray. Okay, here's the copper. We're almost done with all of these. All right. Copper, the precipitates are very gel-like, very goopy, very thick, almost like Jell-O that's almost quite set. Okay, you see it's got this gel kind of goop. I don't know if if you can see it. And then this, we get this very pretty blue color. Okay. And then the last one is iron. So here's your iron nitrate. That one, there's definitely, I'm hearing bubbles, so there is some gas being given off as well. That one definitely is gel-like. It's got this sort of thick consistency. And that one's little gel, well, it's kind of more dissolved. But we have this darker brown. Okay. Now I do want to show you, it might be kind of hard to see, but with this is the first one we did. And if you let it sit, you see a water layer form on top. And you'll see the solid kind of settle out. So now here is just a close-up of all of them so that we can see all of them, and then I will look at the side so you can hopefully see that some of these have settled out and you can see the liquid layer forming on top. So if we look, this is the first column that we did with the silver nitrate and the sodium hydroxide, and we have that brown at the bottom and then we have that liquid layer at the top. All right, and then for the final thing, we need to talk about how you're going to fill out the chart. Okay, so what this chart is, these are the chemicals that were along the top. These are the chemicals that were along the side. This is essentially where the reaction occurred. This is where the reaction occurred. So these would be like my little beakers, the bigger squares. So in this square here, what you're going to do is you're going to write the observations for the silver nitrate and the sodium carbonate. It's the first one in that upper corner of the grid. So this is what it was, okay? So this, I would say, it's slightly yellow. And it's powdery. Now, as I went through this, as I went through the video, I tried to tell you if it was powdery or gel-like or thick and goopy. Okay, so you're gonna do your best. I definitely want colors, and do your best on whether it's gel-like, clumpy, powdery, etc. Now, the product formula, you are going to make a formula between the cation and the anion that's listed underneath the substance. So I am going to form a compound between silver and carbonate. That is what is being formed right here. Okay, so you're gonna, on the side or in your head, Ag is +1, carbonate is a 2-. Remember, the 2 comes down, the 1 comes down, and my product formula is Ag2CO3. Now to name it, remember you're going to use Roman numerals if the element, the cation, is not in 1, 2, or 13, or if it's silver, cadmium, or zinc. Well, this is silver, so I don't need Roman numerals. So I name this. This is silver. I do not need to put the charge in Roman numerals. Okay. CO3 2- is a polyatomic. I look on my polyatomic sheet, and it is carbonate. So the name is silver carbonate. Now, what I would do, what I recommend, is go through this and identify the ones that need Roman numerals and maybe circle them or highlight them. So for example, barium is group 2, it doesn't need Roman numerals. Cobalt's in the middle of the periodic table, it does need Roman numerals. And what Roman numeral would it need? Well, it's a +2, so this would be cobalt, Roman numeral 2. Identify those first, and then you basically putting the names together are going to be very, very easy.